All right, today we're jumping into something big. A brand new research paper that might just change, well, pretty much everything about how we build the massive systems that power our digital lives.
Okay, I'm gonna start with just a number. 67%. That's it, 67%. What in the world could that mean, right? Especially in tech.
Well, get this. That's the percentage of e-commerce sites that chose the wrong tech and then just completely fell apart during Black Friday. We're talking catastrophic failures on the single most important shopping day of the year. This isn't just some small bug, it's a full-blown business disaster. So you gotta ask, how did so many really smart teams get this so incredibly wrong? And what's the fix? That's exactly what we're gonna unpack, and this paper has some wild answers. Okay, first up, the modern data deluge. So to get what's going on, you need to understand the world we live in now. Every app, from your Amazon cart to the latest AI, is basically drowning in data. It's a constant flood. And to handle it, they use something called event-driven architectures. Think of it as the system's nervous system, processing millions of little signals every second. A click here, a purchase there, a sensor reading over there.
But here's the problem. If you're an engineer, you're staring at this menu with way too many options. You've got the big players like Kafka and Pulsar, you've got the super fast ones like Nats, and then there's all the serverless stuff. They all have fancy websites saying they're the best, so how do you possibly pick the right tool for your specific job? It's a mess.
And that brings us to what this paper calls a crisis of comparison. Seriously, trying to compare these systems today is like, imagine you have a Formula One car, a giant cargo truck, and a tiny drone. Now imagine you're trying to figure out which is best, but the F1 car only gets tested on a perfect racetrack, the truck on a brand new highway, and the drone in a calm, empty warehouse. It's not a real comparison. It's not even close to a fair fight.
And this right here just nails the problem. The vendor's marketing says, yeah, we can do 2 million messages a second, under perfect lab conditions. But then you put it into the real world, the production environment, with its messy, spiky traffic, that performance can drop by 40, 50, even 70%. And that gap, right there between the shiny marketing number and reality, that's where companies lose millions of dollars.
The author of the paper doesn't mince words. They say this makes objective comparison impossible. It forces engineers to just trust the marketing hype instead of actual science. In other words, the people building these critical systems, they're flying completely blind. And what's the price of flying blind? A staggering $2.3 million. That wasn't the total loss. That was the average revenue lost per incident for those sites that went down on Black Friday. Just incredible.
The problem is even deeper than just picking the wrong tool. It's that our systems are built to react. When a huge wave of traffic suddenly hits, it takes them on average 45 seconds to wake up and scale up. But in internet time, 45 seconds is an eternity. It's too late. A third of systems failed to handle spikes they were supposedly built for. And we saw this play out in a really serious way during the pandemic. A shocking 89% of healthcare systems just couldn't keep up.
All right, so we've laid out the problem. It's massive, it's expensive, and it's happening right now. So what do we do about it? Well, this brings us to the paper's first huge contribution. They decided to stage the first truly fair fight, a standardized test, a common battleground, where all these systems are tested under the exact same messy, realistic conditions. And the results? Oh, they are fascinating. When you look at just raw speed, what we call throughput, on a typical e-commerce workload, Kafka is an absolute beast, the undisputed king, clearing over 1.2 million messages a second. Pulsar is right up there, a really strong second, but the serverless guys, kind of lagging behind in the speed department. But hey, speed isn't everything, right? This chart here shows us latency. That's the delay, the time you have to wait. Lower is better, and again, Kafka and Pulsar are super snappy, very responsive, but serverless, you see that big jump? There's a much bigger delay. But here's the key takeaway. It's not about who won. It's that for the very first time, we can actually see this trade-off, clear as day, with real numbers.
In this table, this is where it all comes together. Look at this. To get that screaming fast performance from Kafka, it's going to cost you a team of more than 2 full-time engineers just to manage it. But that serverless option, you barely need a third of a person's time. So all that performance comes with a hidden price tag: people and complexity. And finally, with this data, you can actually make an informed decision about that trade-off.
Okay, a fair benchmark is a total game changer, no doubt. But honestly, that's not even the most exciting part of this paper. The researchers took it a massive step further. They asked a question that kind of turns everything we've been doing on its head.
We've seen that these old static rules, this whole model of just reacting to problems, is broken, it's failing. So they asked, what if the system could do more than just react? What if it could actually learn? What if it could predict the future and adapt before anything bad ever happened?
And that is the core idea here, AI-enhanced event orchestration, or AAEO. The best way to think about it is like an AI conductor for an orchestra. It's this super smart brain that you place on top of any of the systems we've talked about, Kafka, Pulsar, you name it. And its job is to make the entire orchestra play better, in perfect harmony, by predicting what's coming next.
So how does this AI Maestro actually work? It's really a beautiful three-step loop. Step 1, predict. It uses machine learning to see the future, to forecast that Black Friday traffic spike before it happens. Step 2, prepare. Based on that prediction, it proactively gets the system ready, scaling everything up ahead of time so there's no lag. And step 3, adapt. In real time, it's intelligently steering traffic, moving it around any potential slowdowns. It's all about predict, prepare, and adopt.
And the results? Okay, this is the jaw-drop moment of the whole paper. Just by adding this AI conductor layer, they saw costs plummet by 42%, latency, that annoying delay, dropped by 34%, and they used 28% fewer resources. And get this, that was across the board for every single system they tested. It literally made everything better.
So let's bring it all home. What does this mean for the future? The paper's conclusion is actually pretty simple, but it's also incredibly profound. For the last decade, our entire industry has been obsessed with one thing, building a faster engine, trying to create the next, quickest, most powerful framework. But what this research screams from the rooftops is that we've been looking in the wrong place. The next big breakthrough isn't a faster engine, it's a smarter driver.
So let's recap the big points. 1, that benchmarking crisis is very real, and it's costing companies a fortune. 2, when you finally test things fairly, you see the critical trade-offs between speed and complexity. 3, the real game changer is adding that AI orchestration layer on top. The gains are just massive. And finally, the future isn't about picking one winner. It's about intelligently conducting them all.
And that leaves us with one final, big question to chew on. What if the next revolution in how we build software isn't some brand new framework at all? What if it's a new layer of intelligence that simply makes all the amazing tools we already have smarter? Something to think about. Thanks for joining this explainer.